Isn't this 2z?
Oh, Marcella asked what this is recorded. Z equals 2, so it's 2 times 2.
Did you leave out the z here? Is that what happened?
Yeah, I said that. The
But
very first thing
I
is
didn't
do
want
the
your
thing
help
where
in the
it's
first
66.
place.
So I said, yeah, I got half that. You didn't do the 2 in front of the z.
Okay, you guys need 18?
Yeah.
Okay. All right, the base.
I would like to.
Alright, I need to leave.
Okay, a baseball diamond is a square with side 90 feet. A batter hits the ball and runs towards first base with the speed of 24 feet per second. So, what rate is his distance from second base decreasing when he is halfway to first base? So here is our triangle, I guess. Are we doing that one? Okay.
I'm confused why we have to draw a triangle when you can't run on that line.
It's not running. It's
When you can't what?
Need that.
Wait, time out. When what?
Why do you need that? The hypothesis.
Oh, so that I can come up with a relationship between these things.
Just do 90
Okay.
plus.
So I don't actually need this in, oh no, what rate is, no, that's what we're trying to find.
Okay, that's what I'm getting really confused.
It's
because I
not,
just think
he's
that
not running that
that's,
way.
I know, but that's what I keep thinking.
Oh,
that
okay,
he's
no,
just
so
running
here's
that
what's happening, basically. He starts out, and this is his distance from where he is to second base, right? And then when he gets right to here, this is his distance from where he is to second base, so, I mean, it's, right? And so it's getting smaller, okay? So this is just the thing that we're measuring, but it's not actually, someone, yeah, he's not gonna run on that line.
Well, I
Okay.
guess I realized that, but it's in tomato.
Okay,
I'm
that
sorry.
is the part that we're trying to find,
The
okay?
emotions in the room right now, though.
Like, I understand the rules.
Okay,
I can't
so
do
this
that.
side you know is 90, okay? This side right here is
90 minus X.
90 minus X.
But
No,
he says he's halfway.
I know, but, my goodness, how many times do you have to go over the warning? Okay? You
No,
have to come up with an equation first, take the derivative, and then substitute the 45, okay?
It's still gonna be 45.
And then
Yeah,
this,
halfway is 45.
and then this is what we're trying to find. What letter do you want for this?
F.
Y, okay, so we're
Y.
trying to find dy dt, okay? I don't care what letter you use there. So we know that 90 squared plus 90 minus x squared is going to equal y squared, correct?
Yeah.
Okay, so we're not going to put in 45 because then we would just get 0. We're going to take the derivative, okay? Now the same thing is in the airplane problem. This right here is a constant.
Okay, so it's
That's
0.
not going to change, right? So that part comes out to be 0. It's not going to affect the problem. What's the derivative of this part here? 2 times 90 minus x to the first power times, no,
X.
no,
X.
closer, negative dx dt.
Why is
Oh,
it
yeah,
negative?
okay.
Because it's a negative X.
Now I
Correct.
know. I know what it
The
is.
XCT is coming from.
And then the derivative of this side is 2y dy dt, all right? We know what x is now, because Bua said it was 45. We know what dx dt is, because it gives us the speed at which they're running to first base. We don't know what y is, but you can figure it out, right? Because you know at this instant that this is 45, this is 90, so you can figure out what that distance is, and then we're trying to find dy dt, okay?
You guys would know why.
90, no, yeah, y is this length right here. We use y as a
So then
hypothesis.
why do we have dy?
Because it's that we're always having that. We're having two things going on at the same time. We have a static picture in which this is 90, 45, and that's the square root of some weird number. And then we have a changing picture where this is dy dt, this is dy dx, and this is
So I just solve for y.
up here. Yes, when x is 45,
What is y?
what is y? And don't make the 90 a 0 anymore. That's only when we take the derivative. What did you get for y?
Why do you have 90?
Because I plugged in 45 for x, 90 minus 45 is 45 times 2 is 90.
And then why did you put another 45 in?
I didn't. What are you talking about? You have no evidence that that ever happened.
Why is it negative 24?
Because the derivative of negative x is negative dx dt. So the x dt, right. And then what did we figure out for y to be? I don't want the square root because I think we're supposed to.
Yeah, I got that.
Root 10125. We can get nothing out of that? Oh, okay.
I'm not gonna waste my time.
What?
Yes.
Alright. And easier is always better.
Definitely want to put a jack board there.
Definitely not. Definitely not. All right, so if you divide, then whenever this is all right, that you just hit these.
I got negative 10.
What number is this?
18.
Did you perhaps get negative
That's
10.7?
what I got.
That's really hard.
If you look at it. Negative 10 plus
That's like,
Because the negative 10.7 is 8%.
yes,
We didn't,
indeed.
we got both of them were positive.
Yeah, I know, I'm trying to look at this.
Oh, yay.
positive.
Okay, now I can do B by myself again.
Did it be the same answer?
Yep,
Is B the same but positive?
yep.
Hey, is B the same but positive?
Yeah.
So I don't have to do any work.
What's that? No, it'll be positive because that distance is increasing, because your picture will look exactly the same but flipped, right? So everything will come out to be exactly the same, except it's increasing distance.
Like,
and
please
decreasing.
call it plotted.
I think that's like.
Okay, what happens now? Are we,
24.
are we going now?
Yeah.
As far as we got, how would you guys do, like 3 of them?
I
Do
did
what I do.
1, 2, 3, 4 by myself.
All right, number 24, a trough is 10 feet long and its ends have the shape of isosceles triangles that are 3 feet across at the top and have a height of 1
I tried to
foot.
do this one, but I kept getting confused.
So 3 feet across and a height of 1 foot,
I drew my picture.
something like that.
I'm not very visual. It just happens.
Why do you have two?
That's your equation.
This is a trough.
Is this a trough?
Yeah.
This is like a sine view.
Oh, you're throwing.
No, dude, I'm going 3 feet.
But I mean, maybe that's another one.
You need another line. For the
Will you just relax, please?
And if you oh,
Yeah.
that looks funky.
Yeah, I know.
That was clear bottom.
Looks kind of weird.
How's that standing up?
Yeah, you can make it kind of flip in your brain so it looks like a prism that's sort of tilted standing up. You have to make this, keep this one in front, make that one in front. All right, so it's 10 feet long.
Now I can't picture it back. Hold on.
And isn't that weird? When
That's
it's
spinning
like
ballerina
that?
thing.
Yeah,
This one's
oh
in
my
front,
gosh.
keep that in front.
That
Um,
is weird. I hated that.
10 feet long and it says, all right, so 3 feet across at the top,
And then down one.
and then the height is 1.
Okay, that might.
Okay?
I got that
If the
one.
trough is being filled with water at a rate of 12 cubic feet per minute. Water going in.
Dear me.
Okay.
Dear me.
So, yes, dV dt equals 12.
I got confused when I had to take the derivative of these.
It says, how fast is the water level rising? So we want to find the HET when the water is 6 inches deep. So Pua, the height is 6, but we're not going to mess with that until very
Or half a foot.
or half a foot.
Yeah, half,
Is
yeah.
everything else in? Okay, good. Thank you for saving my life.
I caught on
I'm
this.
forever in your debt. What problem number is this?
24.
24. Okay, so now we need to figure out the volume of this trough. We need a straight up
The
formula
base of the
for the
triangle
volume.
is the-
Okay, it's the area of the triangle
Yeah.
times the depth of the thing. Okay, so what is the area of the triangle?
1/2 the base height.
1/2 base times height and then times 10. So that's going to come out to be 5 times the base times the height, okay? But we are once again in one of those situations where we have too many variables here.
Yeah, that's what,
And so we need to use little similar triangles to figure out the relationship between the height of the water at any point and the base. And this would be half the base. So what's the relationship between, well, I'm just going to go with the whole base. What's the relationship between the height of the trough and the base? No,
I can't see.
not double. The height is 1.
1/3.
The base is 3, yeah, so the height is always going to be 1/3 of the base. So h equals 1/3.
How are you supposed to do that?
There you go. Thank you, Mr. Wade. I don't know by looking at the thing. We want to find the HDT, right? So we need to have an H in our problem. So we don't want to plug this in for H. We want to say that B equals 3 times H and substitute that into here and say that really our volume is going to be 15 H squared. And now
I can see
we
why.
are.
Now it makes
You can
sense.
see why what?
I didn't get
Right. So now you take the derivative.
now it makes sense.
Yep, now it should be easy. So dV dt equals 30 H times the HDT. You know what dV dt is, you know what the height is, you're trying to find the HDT, plug them in, solve, be happy. All right, 26. So does that mean when I did my little cut and paste that I missed something?
No, you got it, but like in our book, you
I
have to
got
like
it.
keep going back and forth, back and forth.
Why? What's the, oh, I see.
Yeah.
Okay. All right, number 26. A swimming pool, oh boy, is 20 feet
This
wide.
is awful, I'm just
Yeah,
gonna
it
say
does.
that.
I was Taylor Crew on this one. A swimming pool is 20 feet wide. A swimming pool is 20 feet wide, 40 feet long, 3 feet deep at the shallow end, 9 feet deep at its deepest point. A cross section is shown in the figure. If the pool is being filled at a rate, aha! What do we have? Yeah, we have a rate, so we know the VDT equals 0.8 cubic feet per minute. Okay? So you just write a formula, take the derivative, plug that in, and you're good.
The formula is the
Let's
positive
move on.
number.
All right. If the pool is being filled at a rate of da-da-da-da, how fast is the water level rising when the depth at the deepest point is 5 feet? Okay, so the first thing, yeah, so that's the height of the water right here. So the first thing that you should sort of recognize is we're trying to find the HDT. Again, seems to be a common theme. And we know that at that moment in time, the height will be
So it
5
doesn't
feet.
even really
So
matter
we
that
just need
it's
to-
2 things.
Right, so the other thing that you should notice is that since we're only concerned about when the depth of the water is 5 feet, this whole rectangular area on top we don't care about. So we're really just looking at this trapezoidal piece right there, okay? So we need to come up with a formula for the volume of that trapezoidal trough or basin, recalling that it is 20 feet wide. So this extends in this direction 20 feet.
I don't remember.
Okay, well, what's the formula for, anybody know that, Gabe?
Yeah, because I tried to do it. B1 plus B2 divided by
Good, yeah, the average of the basis, so 1/2 V1 plus V2 times height. And then to turn that into the volume, we're going to multiply that by 20, okay? So, here's one good thing. If we take this to be one of the bases, that doesn't change, right? That is always going to be 12. So if you go 1/2 of 12 plus, the bad news is that this is going to change as the water fills in. Okay? So B2 is a variable, and I'm going to have to find some sort of relationship between that and the height because I have 2 variable quantities here. Okay? But they are going to be related. What's that? at that moment, but remember that's the last thing you do is plug that in, okay? Right, the warning, all right, times the width of the pool is 20,
So can we just
okay?
make it 10 up front?
Yeah, so let's make the 20 and a half be a 10. So this is gonna be 10 times 12 plus base 2 times 8, okay? So the challenge, see now this is why.
I was like,
It was
No, not really. We need to find a relationship
It's one
again
foot.
between this height and the,
No, it's
this
not.
thing
It's not
right
one
here,
foot.
okay? And it's not because it changes on that side and on that side at the same time, yeah. What, the 20? The 20 is the, it says the pool is 20 feet wide. So they
so
didn't
that's
make,
the-
they're not as cool as me, they didn't make the 3D drawing, they just went two-dimensional, okay? All right, so we need to figure out a relationship between those two things, okay? So what they've got going for us over here is that since this is 6, and this is 6, this is going to be a like one-to-one relationship. What?
Yeah,
No, I'm not. We're not. Forget
I
about the
understand what
5
you're doing
part.
right now.
Forget about the 5 part. So over here, if I just consider this little section over here, this height and this distance are going to be the same always, right? Over here, since this piece is 16 and this height is 6, this piece and this are going to be, what's the relationship there?
3, 4, 5. No.
6, 7, 8. What's the relationship here between the how much this distance is and the height? Well, this is 16 and this is 6, right? And it's always going to be the same proportion. So I don't know, y over h is going to be in the ratio of 16 to 6 always. Okay? How do you like that so far?
No, I don't.
Beautiful. What's that do?
What's y?
And then this section right here
What is y?
will always be 12, okay? So one thing that we can say about this whole base is that it is going to be,
Wait, what base?
this whole, yeah, the base B2 that we're trying to find is it's equal to this little piece right here, which is the same as the height, right? So that's going to be h, plus this little piece right here, which will always be 12, plus this little piece right here, which if I take this little proportion that I set up, shows us that h will equal 6y over 16, which is 3y over 8. Y is this piece of the base that we're trying to figure out what it
But
is.
I'm confused. I thought we didn't want to put it in a variable.
Oh yeah, so I don't want to solve for y, I want to solve that for, I'm sorry, I don't want to solve that for h, I want to solve that for y, you're right. So h is equal, no, I just did that. Sorry, y is equal to, if I cross multiply and divide, 16h over 6, or 8h over 3, okay? So what I did, and I didn't explain myself very well, is I took
I
this.
see what you did now.
You see what I did now?
I
You're
See what I
adding it
did
all
there?
together.
Okay, yeah, so I took this whole base that we're trying to figure out what it is, and I broke it down into 3 pieces. Okay? This piece will, no. This piece is always going to be the same as the height. This piece is always going to be 12, and then we figured out from this little proportion here that this piece will always be 8/3 of the height. Why isn't this piece always 16?
It's not, it's just.
Because it's only 16 when it gets up to that level.
I'm confused. There's too many lines.
I know,
I was
it's
little bit
a gross
confused.
little drawing. Okay, so that's h plus 12 plus 8h over 3,
Now I have to plug
which
that in for
well, let's
B2.
simplify it a little bit first. Okay, this is going to be like 3h over 3, so this is going to be 11h over 3 plus 12. Okay, so yes, now we can plug that in for B2. So it's going to be 10 times 12 plus 11h over 3 plus 12 times h. Okay? Which would simplify, then take the derivative, then plug in, yes, Mary, that is the appropriate response.
24
12 plus 12 is 24, times 10 is 240, times h is 240h. 10 times 11 is 110h over 3 times h is going to be 110h squared over 3. And so that is what you get to take the derivative of 240h plus 110h squared over 3.
Take the derivative.
Yeah, so what's the derivative of that mess? 240 plus, so dv dt equals 240 dh dt. You get your old friend the chain rule, plus 220 over 3 h dh dt. Okay? So you know what dv dt is, you want to find dh dt, so that's going to be a little bit gross because there's two of those in there. And then now, where is she? Raina, you can plug in 5 for h. Okay. Right?
I'm almost out of.
Okay, gravel is being dumped from a conveyor belt.
There's so many problems left.
That's okay. At a rate of...
Brandon Thomas.
That's all right. At a rate of 30 cubic feet per minute. So once again, we know the VDT is equal to 30 cubic feet per minute. Okay? Now this is a handy little thing. The coarseness of the gravel is such that it forms a pile in the shape of a cone whose base diameter and height are always
Oh,
equal.
that's really nice.
Yeah, so the diameter, the width all the way across the pile and the height of the pile will always be the same.
That's
That doesn't
great.
even
Yeah,
sound possible.
yeah, no, not possible at all. Plus, you like this little tip of the cone right here, that the gravel's forming and it just falls perfectly laid right on there. How fast is the height of the pile increasing? So once again, we're looking for the HVT when the pile is 10 feet high. Okay? So this one is not nearly so bad. Yes, Mary?
Because it's getting us.
Uh,
They're up there.
yes.
They're-
No, they're gone.
It
Oh.
looks like it's like the radius.
The way they put their what?
Congruent symbol, it's like
Congruent symbol?
The 2 lines.
Oh, on this one here?
And in other news, doesn't those things look like swastikas?
In other news. Okay.
The end one does.
All right, so we need to come up with the formula for the volume of a cone.
This book's not.
We need to
1/3
come
pi r squared.
H. Okay, so again, we have two variables, and hopefully one of the things that you're learning is that there are two different cases. One case is where one appears to be a variable, but it actually doesn't change. So when you had the problem with the cylinder and the water was increasing, the radius was constant. So that's not a problem. The airplane flying, right, its distance from the ground didn't change. So that was actually constant. The base runner running, the distance between the two bases, constant, didn't change. But in this case, the height is changing and the radius is changing at the same time. Okay, so in that case, that's when you have to find a relationship between these two variables. Okay, well, we know that the diameter is equal to the height, always. Okay, so 2 times the radius equals the height, so the radius, but we want the height, we want that, no, we want r equals h over 2. Because we want an h in our problem, because they're not asking us how does the radius change, they're asking us how does the height change. So this becomes 1/3 pi times h squared over 4 times h, okay? Which is pi over 12 h cubed. So now the derivative of that is dt 3 times pi over 4 in the stuff, figure it out.
They are sometimes they're not.
Okay, Boyle's law states that when you know Boyle's law already, right?
No.
Yeah.
Yeah, we did this problem, we did a problem like this on the
No,
other one. Okay, so
Hey, Ray.
PV equals C, okay? So they give us the equation right there, all right? Now the fun part here is that we need to use the product rule, because these are two variables and they're being multiplied together. So I need to go the first one times the derivative of the second one, plus the second one, yeah, I don't know what just happened there, times the derivative of the first, and then what's the derivative of C? 0. Okay? Alright, I don't know why I jumped to the end of the story there. I was so excited to use the product rule, I just couldn't contain myself. Alright, suppose at a certain instant the volume is 600 cubic centimeters, so V equals 600. The pressure is 150 kilopascals. And the pressure is increasing at a rate of, so that means dP dt 20 kilopascals per minute. At what rate is the volume decreasing at this instant? So yeah, that is easy. You know everything you need to know. You just plug all the stuff in and solve for dB dt. The only tricks there were to recognize that C is a constant, so its derivative is 0, and also that you need to use the product rule when you're taking the derivative. Two carts, A and B, are connected by a rope 39 feet long that passes over a pulley P. The point Q is on the floor 12 feet directly beneath P and between the two carts. Cart A is being pulled away from Q at a speed of 2 feet per second. How fast is cart B moving towards Q at the instant when cart A is 5 feet from Q?
He says
Okay.
physics
Too
all
much like
over it.
physics.
I know, anytime you see a pulley, you should totally
We
panic.
just like, omit
Okay, so here's our drawing. And we know that this is going to be 12 feet. And what we are going to do is we are going to call this X, and we're going to call this Y. All right?
Oh, we're just making a triangle out of it, something that's not a triangle.
It's a triangle.
It's a loose triangle.
Okay.
So is your.
Okay, and then here are the things that we know. We know that the X dt is what? The X dt is, we're going to go with -2 because it's saying that the car is being pulled in the negative direction. Okay? And then we did a problem in pre-calculus today where we had negative time. And it was okay.
The time is going
So
backwards.
you had a
No, they
backward.
said noon is 0, 11 a.m. is t equals -1.
That's all your
I
fault.
know, right?
Well, you could have gone all the way
Okay,
around.
how fast is cart B moving toward Q? So we are trying to find the y dt. Okay, and I think that our answer should come out to be negative because it's also moving in the
Why
negative
didn't
direction.
we make it D, A, and
I don't know. And then we want this when cart A is 5 feet from Q, so this is at the time when x equals 5. All right? So the fun part of this problem is that we're going to use the Pythagorean theorem. And we're going to do it twice. Yeah, we're going to use that in a second right here. So to find this piece of the rope right here, I would go x squared plus 12 squared and take the square root, right? Right?
Right.
And then to find this length of rope right here, I would go y squared plus 12 squared and take the square root. And if I add those together, then that equals the length of the rope, which is 39. Okay? So now, we are going to take the derivative of that. Oh, good Lord. Do we have time?
Why did you have the book ripped out?
Just in case I get confused, I need to see what I'm supposed to do. Those are my notes.
1/2.
Okay, right, so we take this to the 1/2 power. So we're gonna go 1/2 times all of this stuff stays the same to the negative 1/2.
2x.
Okay, right, times the derivative of the stuff inside, which is 2x dx dt. Okay? Yep, chain rule inside of that whole mess. Same thing with that. That's going to be move the 1/2 in front, move the power to the front. Subtract 1 from the exponent times again 2y dt. And then the derivative of 39 is 0. So that has to equal 0. Okay? Didn't hardly fit on my paper either. Okay, we know what x is. It's 5. We know what the x dt is. It's -2. We do not, however, know what y is. Okay? But we have the technology. We can take and substitute in here 5, because at that moment, that distance is 5.
You can say like 5 minus y, like y minus, because like you have the distance in the triangle.
Right.
So you can find the bottom, like x plus y equals.
Right, gotcha. Yeah, okay. So that will tell us what y is, and then we need to know what dy dt is. Okay, so as soon as we figure out this here, which is, this comes out to be 13, right? If I subtract 13 from both sides, then that gives me the square root of y squared plus 144 equals 26. Square both sides, so y squared plus 144 equals 625, what is it? 670, okay, 676. Subtract 144 from both sides, and you get 532. So y equals the square root of 532, which I'm assuming is not a whole number. Okay? All right, so that's your assignment for tomorrow, is to finish this problem. Plug in 5 for x, plug in -2 for this, plug in the square root of 532 for y, and solve for dy dt.
Who's going to handle that?
And then tomorrow we will wrap it up.